We are here at the main lecture theatre in the physics department at Imperial, and we are going to be looking at superconductors with Dr. Simon Foster. But first, over to Megan for the science. This is a normal material on a magnet. As you can see, the magnetic fields pass straight through it. This is YBCO over magnet. When YBCO is supercooled, it becomes a superconductor and repels the magnetic fields, making it float. Simon is about to supercool the YBCO and then place it on the track of magnets.
Here we go.
He's supercooling with liquid nitrogen.
So, at minus 200 degrees, I'm just pouring it in this very carefully cut polystyrene cup, as you can see here. And if we look inside, you can see the liquid nitrogen boiling as it cools down our superconductor in there. So, actually, it only takes a few seconds, so we might be in luck. We can just go straight to this. As you can see, I'm using tongs because this stuff is very cold. So let's stick it on the track and see how we get on. See it floating around until it obviously loses that one's not so good. So you can see this used to be a nice perfect disc until it broke into many different pieces, unfortunately. But these are all different magnets. They've got north-south, so it kind of it helps it float along. Look underneath. See it just, and hopefully this is how one day maglev trains will work.
Why is research into superconductors so important?
Well, there's several different elements. One of them is obviously, as we've seen here, if we can make magnetic levitation a real possibility at everyday temperatures, then you could have trains to be able to shoot up and down at super fast speeds and be able to get from London to Edinburgh or London to Manchester really quick because you wouldn't have any resistance, you wouldn't need the tracks. That's one really important thing. The other thing is, obviously, when you have a superconductor, it's got no electrical resistance anymore. It's a perfect conductor. And this will be really important because, obviously, at the moment, we lose loads of energy kind of transporting electricity from the power station to where we need it around us, and it gets lost in the wires. If we could have a superconductor, you wouldn't lose that. And the other thing is, if we could have really good conductors like this, we could make excellent batteries that would hold the charge for really long periods of time. And that's really important in this kind of world where we've got trouble with energy. So that's why there's lots of research into this.
Thank you. This is Science Rocks.